Anyone remembers what delta y represents, and I'm going to write it here, and what dy represents, and I'm going to write it here?
I think delta y is the exact error.
Change or error, very good. Perfect. And this name is very important. Anyone remembers?
The approximate error.
Yes, the approximate error, but it has a specific name. It is the approximate. That's correct. The approximate change or error, of course, in y. The same thing here, in y. Change in y. What is the name and what does it equal to? So the name is?
I don't remember that. Differential.
Very good. Of y. And what does it equal to?
I think the part where you wrote already, the approximate change?
Yes, but there is a formula. Yes, everything is correct here. But there is a formula for dy. Yes. Awesome.
F prime of x dx.
Excellent. Good. So now, knowing that what this is, the exact, and knowing that this is the approximate, what is the symbol between these two? We have many symbols. We have this, 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 we have this. Which one?
The approximate.
Yes, of course. This is the symbol. Very good. They are very close. Okay, item 3 here. Derivative and differential of a function are or are not the same.
Are not.
Very good. Of course they're not. The derivative is only this. The differential is this product. They are not. Perfect. A function can or cannot be approximated by its tangent line at the point. Of course, near that point. True or false? A function can or cannot be approximated by its tangent line at the point. Near that point.
Can.
Yes, of course. We just discussed that. Because f of x is approximately the linearization. Perfect. Final question here. That's all I have for today. Related rates are ... of functions found in an or related by an. Related rates are of functions found in an what are related rates, basically?
They're functions of each other?
No? That's
of
okay.
time.
No. Yes, you're right, but let's go back. So these are the two functions related here. These are the two derivatives, the derivative of this and the derivative of this, related by another what? What is this? It has a left-hand side, an equal symbol, and the right-hand side. How do we call something like that? A left side, a right side, and an equal symbol. How is this called? When we set two quantities equal to each other, what do we form? Say it again.
An equation.
Yes, of course. It's an equation. So related rates are derivatives of functions found in an equation. Or if you don't want to say found in an equation, you will say or related by an equation. Same thing. Awesome. Any questions on this? Okay, then perfect. Page 2, the floor is open for any questions. Anything you want to ask. Yes, Cameron, you want to start? Do you have the problems? I don't remember. If not,
I do, and it is number 2 and 3.7 web assign.
Okay, perfect. Do I have to open or can you read it?
I can read it. So it's another particle question. And so the function is f of t equals sine pi t over 2.
Good?
A is, yep. And then we just jump right into the 5 or 6 questions, however many they are. So
right. So we are given t. Anything about t?
Oh, greater than or equal to 0. Sorry.
Okay, that's okay. So I'm assuming the first question would be the velocity.
Yes.
Okay. So we want to differentiate this. Can anyone help us quickly on how to differentiate this piece?
The actual differentiation, or just the
process? The derivative.
Or yeah, that cosine pi t over 2 times pi over 2. Very
good. Awesome. Then I think in part 2 we're asked to find the v of something, or is this still part 1? Okay, v of 1. Good. So cosine pi over 2 times pi over 2. So how much is cosine pi over 2?
Is 0.
Yes. Perfect. Okay. What was this third question?
When is it at rest? And it says use the parameter n as necessary.
So at rest, what do we mean by at rest? What is our velocity when we sit?
0.
Yes. So the velocity is 0 at rest. Here's the velocity. So we have pi over 2 cosine pi t over 2 equals 0. So of course I'm going to divide both sides by pi over 2. So I only have cosine pi t over 2 equals 0. So are they telling us how many times we go around the circle, or are they indicated anything here?
Nope, it just says use the parameter n as necessary to represent any integer.
Okay, so remember, cosine is measured on the x-axis. So at these 2 points, cosine will be 0. Here, 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 here. So pi t over 2 can be 0, or pi, sorry. So here is where cosine is 0, sorry. So this is 1 and this is -1. So pi over 2 and 3 pi over 2. So pi over 2 or pi t over 2 equals 3 pi over 2. So here is cosine 0. Here is 1 and here is -1, because it's measured on the y-axis, on the x-axis. So here's 1, here's -1. So at pi over 2 and 3 pi over 2, cosine of pi over 2 is 0, and cosine 3 pi over 2 is 0. So from here, we have to find t. So I will divide both sides by pi over 2, and I get t equals 1. Same thing here. I divide both sides by pi over 2, and I get t equals 3. And where do we stop? I know they said t greater than or equals 0, but are they telling us later on the first 6 seconds, 10 seconds, or they're not saying anything?
No, nothing.
Okay, so let me
the video, when they start talking about the parameter n, it was like there was something I was supposed to know from trig or something, and I don't know what that is.
Yes. So what that is the following. So here t equals 1, and I have to write t equals 1 plus 2 pi k, where k is 0, 1, 2, and so on and so forth. The same thing here, plus 2 pi k. K is an integer. So what does this mean? It means that there are infinitely many solutions. So t equals 1. So at this point, cosine is 0. But also if I add 2 pi, I land here and I also get 0. If I add 4 pi, another complete rotation, I get back here. If I add 6 pi, I get back here. So that's what it means. When k is 0, I have 1. When k is 1, I have 1 plus 2 pi. When k is 2, I have 1 plus 4 pi. When k is 3, and so on and so forth. Okay? So I have to have multiples. Now, why this works is because, I get these two solutions at all times. So one more time. I have 1 plus 2 pi. And then I have 1 plus 4 pi. And then I have 1 plus 6 pi. And the same thing here with 3. Does it make sense?
Yeah.
So this point here is for t equals 3. But if I add another complete rotation, I cannot add, normally k can be also negative. So normally we write that k equals 0 plus or minus 1 plus or minus 2, but this is not the case here because we are talking about time and we are told that t has to be greater than or equal to 0. That's why I did not choose the negative option. But otherwise I would have, right? So if I'm here, I can get here again by adding 2 pi or by subtracting 2 pi. So that's why k could be negative, but not in this case. Okay, what is question number 4?
The when is it moving in a positive direction for 0 less than or equal to t less than or equal to 6?
So that's what I thought. That's what I was thinking. Okay, so they basically want till 6. So then I will probably have to continue here, but we'll see. Because that is a problem now. So t and v of t, and I'm assuming they're going to ask a of t as well. So, and then we'll check. We'll check how many more solutions. So definitely 1, the velocity is 0. Definitely 3, and the velocity is 0. So now let's see what happens. 1 plus 4 pi. 1 plus 4 pi, luckily for us, it will exceed 6. So we don't have to worry about it. Okay? So that's all we need. Perfect. Now, in order to find the sign here, I will have to plug in the velocity. This is not important because this is not going to give us any sign. I will have to plug in the velocity numbers like 0, 2, and 5 to see the sign here. So if I plug in, I can 0 because, yes, I can 0, yes, because it's 1, so it's positive, I can. Now I'm going to plug in 2. 2 over 2 is 1, cosine pi is negative. Now I'm going to plug in 4. 4 over 2 is 2, and 2 pi cosine 2 pi is positive. So then I already know it's going in the positive direction between 0 and 1, union between 3 and 6. You don't have to write it on paper for me for the test. It's sufficient. I understand it from here. If you put the positive and the negative and the positive, I know that this is what you mean. You mean that the particle is going in positive direction between 0 and 1 and 3 and 6. You don't have to separate it, okay? So I don't need you to write. It's okay if you do. You can say particle in positive direction for 0 to 1, union 3 to 6. This is not required because I see it here. Particle in the negative direction for t between 1 and 3. There is no need to write that. If you have it in the table, I'm super happy. There is no need. But now for WebAssign, you have to have these. Excellent. Number 5.
That's the draw the diagram and give the total distance. But I guess before we start on that, it's like
You accidentally muted yourself.
I did. That was funny. I guess my problem is that when I'm putting this stuff in, it's telling me we're wrong. And so
what do you say? The stuff in, you're saying the intervals?
that answer it said was wrong. Yep.
0 to 1, union 3 to 6?
Yep. And so that's why I was like talking with you about maybe doing it after class, because I can't tell if I'm doing the work right because it's just telling me I'm wrong, and I don't know if it's notation. I don't know if it that's what's causing my frustration right now.
Yes, it is frustrating. So let's take a look for a second. I'm gonna open it right now, so see what is going on there. Okay, and this was, you said, problem 2. Maybe we copied, or maybe I copied something incorrectly. So this was in 3.7. Okay, I'm clicking on 3.7 right now. Okay, almost there. And you said problem 2. So I said to enter parentheses. You entered brackets.
I did both. I changed it just in case because it told me parentheses was wrong.
No, something. But they have to be parentheses.
I would agree with you, but WebAssign doesn't agree with me.
But it is 0, 1 to 3, 6, isn't it?
I mean, I agree with you, but it doesn't agree. And so getting to the frustrating time is how much time I'm spending trying to get the scores, and I don't think it's my math.
Okay.
I just tried it with parentheses too, and it said it was wrong.
But it has to be parentheses.
What's the original? I'm sorry. I just want to make sure we're doing I have the same number too. What's the original? Is it sine?
Sine pi t over 2.
My correct answer is 0 to 1, union 3 to 5.
So this was,
of course.
Okay, so this was 3 pi over 2. So pi t over 2. Oh, okay, so the 3 is okay. It means that there is one more solution. That's what it means. Okay, so then pi t over 2 equals pi over 2 plus 2 pi. Pi over 2 plus 2 pi. Okay, let's see what happens here. Okay, so it means that there is a third solution. I stopped at 3, but we have to continue. That's what it is. So pi over 2 plus 2 pi. So we have pi t over 2. So this is 5 pi over 2. So yes, t equals 5. So there is another solution here. So there is another 0 here. So it means that this part is negative, and we'll check in a minute with 6. We have to check. Okay, very good. So that's what it is. So there are 3 solutions, not just 2. So checking cosine with 4 one more time. Cosine with 40 was 2 pi, so that is positive. Cosine with 6, yes. Cosine with 6 is negative, yes. Perfect, thank you so much. We can, as I mentioned, we can stop. I stopped at the second solution, but I still have to go back and add with k equals 1, but because we're not exceeding 6 here. We're exceeding 6 here, but not here. Good, awesome. So then we have in the positive direction between 0 and 1 and 3 and 5, and negative direction between 1 and 3, union 5 to 6. All intervals must be open. Do not try brackets, please, because it's about tendency. It's not about value. Very good, awesome.